teenage girl is strapped into a ride that promises a few seconds of weightlessness. The machine begins to spin. Faster. Then faster still. Spectators watch as the massive arm swings overhead. At first, everything looks normal. The riders scream. Parents laugh. Operators monitor the controls. Then a loud crack echoes across the midway. A section of the ride suddenly breaks apart in midair. Passengers are thrown from their seats. Bodies slam into the ground in front of horrified families. Within seconds, a summer day at an amusement park turns into a scene of chaos, ambulances, and panic. And shockingly, that wasn't even the deadliest amusement ride disaster in history. Amusement parks are designed to do one thing: create controlled fear. Visitors willingly climb into machines that flip them upside down, launch them through the air, or drop them from towering heights. Millions of people ride them every year without incident. But when something does go wrong, the consequences can be catastrophic. Mechanical failures, design flaws, human error, missing safety checks. Over the decades, a handful of ride accidents have left permanent scars on the industry and changed safety regulations around the world. These are some of the worst amusement park ride disasters in history, and the final case involves a disaster so severe that it remains one of the deadliest amusement ride accidents ever recorded. Case 1. The Smiler Disaster, 2015. On June 2nd, 2015, visitors flood into the gates of Alton Towers, one of Britain's most famous theme parks. Among the attractions is a roller coaster called the Smiler. The ride is famous for its complexity. 14 inversions, twists, turns, dot loops. At the time, it holds the world record for the most inversions on a roller coaster. That afternoon, 2 trains are operating on the track. One of them develops a problem and stops unexpectedly on the course. Normally, safety systems are designed specifically to prevent another train from entering the same section. But a chain of mistakes begins to unfold. Operators believe the track is clear. Attempts are made to override warning systems. Meanwhile, another train carrying 16 passengers climbs toward the stalled car. The riders have no idea what is ahead. At nearly 50 miles per hour, the moving train rounds a bend. Then the impossible happens. It slams directly into the stationary train. The impact is devastating. Passengers are crushed inside the wreckage. Metal folds around the front rows. Emergency crews spend hours cutting victims free. Several riders suffer life-changing injuries. 2 young passengers, Leah Washington and Joe Pugh, eventually require leg amputations. Investigators later determined that human error played a major role. The park's operator faces prosecution and significant fines. The accident becomes one of the most serious roller coaster crashes in modern British history. For many visitors, it destroys the assumption that computerized safety systems can never fail, but the next disaster doesn't involve a collision. It involves a ride literally tearing itself apart while people are still on it. Case 2. The Fireball Tragedy, 2017. In July 2017, crowds gather at the Ohio State Fair. The midway is packed. Music blasts from speakers. Families move between food stands and attractions. One of the most popular rides is called Fireball. The machine consists of a giant swinging arm with a circular gondola attached at one end. As it swings higher and higher, riders experience intense forces and moments of near inversion. Just before 8:30 p.m., a cycle begins. Passengers are secured in their seats. The arm starts swinging. Everything appears normal. Then witnesses hear a loud metallic snap. A support beam fractures. The gondola suddenly separates. Sections of the ride break apart while moving at high speed. Several passengers are launched through the air. One victim is thrown dozens of feet. People on the ground dive for cover. Others freeze in disbelief. Within moments, emergency personnel rush into the scene. 18-year-old Tyler Jarrell is killed. Multiple others suffer severe injuries, including broken bones and internal trauma. Investigators later discover extensive corrosion inside a support beam. The deterioration had developed internally, making it difficult to detect during routine visual inspections. The findings shock amusement ride regulators. If corrosion could remain hidden inside critical components, how many other rides might have similar vulnerabilities? The accident triggers nationwide inspections of similar attractions. Thousands of rides are examined. Many are temporarily shut down. But hidden corrosion isn't the only danger. Sometimes the threat comes from a ride operating exactly as designed.
Case 3. The Verrückt water slide disaster, 2016. In 2016, visitors arrive at Schlitterbahn, Kansas City to experience one of the most extreme water slides ever built. Its name is Verrückt. The German word roughly translates to insane. The slide stands approximately 168 feet tall. For comparison, that's taller than many urban skyscrapers. Riders climb hundreds of steps before entering a raft designed to carry multiple passengers. The descent is terrifying. A near vertical drop, massive speed, then a second hill intended to create a sensation of weightlessness. But from the beginning, engineers and operators struggle with problems. Rafts occasionally become airborne. Sandbags are used during testing. Design modifications are made. Concerns continue to surface. On August 7th, 2016, 10-year-old Caleb Schwab boards the ride. The raft begins its descent. It accelerates rapidly down the giant drop. As it approaches the second hill, something goes catastrophically wrong. The raft lifts violently. Caleb strikes overhead metal structures. The impact is fatal. Other passengers in the raft suffer injuries. Witnesses are horrified. Some initially struggle to comprehend what has happened. The world's tallest water slide suddenly becomes the site of one of the most infamous ride disasters ever recorded. Investigations reveal serious concerns involving design, engineering review, and safety oversight. The ride is permanently closed. Later, it is demolished. The tragedy sparks intense scrutiny of amusement ride regulation in the United States. Yet, even this disaster isn't the deadliest on this list. To find that, we have to go back decades. Case 4, the Big Dipper Collapse, 1972. In June 1972, visitors stream into Battersea Park Fun Fair. One attraction dominates the skyline, a wooden roller coaster called the Big Dipper. The ride has operated for years. Many locals view it as a beloved landmark. That afternoon, a train begins climbing the track. Families sit together. Children look out over the park. Nothing appears unusual. Then disaster strikes. As the train negotiates a section of track, a hauling rope becomes detached. Without proper control, part of the train behaves unpredictably. Cars derail. Passengers are thrown from the coaster. Bodies tumble onto the wooden structure below. Panic spreads through the amusement park. Emergency crews race to the scene. By the end of the incident, 5 children are dead. More than a dozen other people are injured. The tragedy devastates families and shocks Britain. Investigators discover serious maintenance and safety issues. Questions emerge about inspections, operational procedures, and the aging ride itself. The Big Dipper is eventually dismantled. The disaster becomes one of the worst roller coaster accidents in British history. For years afterward, it serves as a warning about what can happen when aging attractions continue operating without adequate safeguards. Yet, even 5 deaths are not enough to place this accident at the top of the list, because the final case involved a disaster so catastrophic that it killed dozens of people in a single moment. Case 5, the Castle Bravo disaster, 1981. On May 9th, 1981, families visit a traveling amusement fair in Mexico City. Among the attractions is a ride known as Castle Bravo. Unlike modern computerized rides, many traveling fair attractions of the era rely heavily on manual assembly and transport. Components are repeatedly dismantled, moved, and rebuilt. Each setup introduces opportunities for mistakes. Throughout the day, visitors board the ride without incident. Nothing appears unusual. As evening approaches, another cycle begins. Passengers take their seats. The machinery starts moving. Then catastrophe unfolds. Reports indicate that a critical structural failure occurs while the ride is operating. The massive attraction collapses. Metal crashes into crowded areas. Passengers are trapped beneath twisted wreckage. Witnesses run toward the scene. Others flee in terror. The destruction is overwhelming. Emergency services struggle to manage the scale of the disaster. Victims are scattered across the area. Families search desperately for loved ones. By the time the rescue effort concludes, the death toll reaches approximately 32 people, with many more injured. Investigations focus on structural integrity, maintenance practices, and inspection standards. The tragedy highlights a persistent challenge within the amusement industry. Unlike permanent parks, traveling rides experience constant stress from transportation, repeated assembly, and varying operating conditions. Every bolt, every support beam, every connection point matters. When one critical component fails, the results can be catastrophic. More than 4 decades later, the disaster remains a grim reminder of how quickly entertainment can transform into tragedy. Millions of people visit amusement parks every year and return home with nothing more than memories and photographs. But these disasters reveal how fragile that sense of safety can be when engineering failures, maintenance mistakes, or human error intersect at exactly the wrong moment. The next time a ride climbs a towering hill or swings high above the ground, one question lingers in the background. How much trust do people place in machines they barely understand? For more true stories of disasters, survival, history, and the moments that change safety forever, stay with the channel. The next story is already waiting.